Hello guys, welcome to day 13 of our video journal. Let's begin with our problem. Okay, so question number 918, maximum sum circular subarray. So let me see, just whenever you think subarray, think of the cadence algorithm. The cadence algorithm, the simplest one, is the easiest way to find a maximum subarray in a regular array. So let's see if this comes up somewhere during the question description. Given a circular integer array nums of length n, return the maximum possible sum of a non-empty subarray of nums. So it seems like the only twist on the original question with Caden's algorithm is that the array that we're given is circular. A circular array means the end of the array connects to the beginning of the array. Formally, next element of nums I is nums I plus 1 modulo n. Sweet. I'm sure visually a circular array makes complete sense. It is an array where the value after the last value is the first value. Okay, a subarray may only include each element from the fixed buffer nums at most once. So they can't, Formally, a subarray num I plus 1 to num j, where there does not exist an I that is smaller than k1, k2 smaller than j. I'm not sure exactly what that's saying, but oh, so it's saying, it's just saying that wrapping around the array like this, there can't be an I and a j that are the same. Let's look at some examples. Example number 1 is nums is 1, -2, 3. Just visually, I can see that the max subarray is going to be this one value. However, in example 2, in the traditional sense of this question, in the traditional question, this answer would actually be 7, because you would have to include both of the positive 5s as well as the -3 integer. And here, you can wrap around, since it's a circular array. Okay, so I guess there are two possible solutions. First, let me show you how the cadence algorithm is implemented. You have something called a local maximum and a global maximum. And then all that you would do is for number in nums, you would say local max is equal to max of n, or n plus local max, and then global max equals max local max global max. Return global max. Let's see how Yeah. In the traditional scenario, this works out perfectly because here we're not wrapping around to create something bigger than the traditional max subarray. However, in the case where we do wrap around, the question becomes, the expected is 10, but the reality is, in the traditional sense, it would have been 7. Let's see what case number 3 does. Also, if you're just watching the video, I do eventually solve, so stick around to the end or skip. In this case, it would be -2. You know what I did not do? I did not do this. Nums 0, nums 0. Yeah, now this one is going to be correct as well. Although, at this point, we've solved the max subarray. I'm going to quickly talk about what is actually happening. This is, think of the problem as a two-stage problem. Obviously, the last portion of this problem is that we want the globally maximum subarray, or the maximum subarray within the whole array. But for the purpose of understanding the question better, let's dissect into another portion of this problem where we try to figure out what is the maximum subarray for any given index, for any given, what is the maximum subarray ending at a specific index. So the maximum subarray of, for example, the maximum subarray ending at index 0, the maximum subarray of ending at index 1, and so on. Clearly, or I don't know if it is clear, but intuitively you could say that the maximum array ending at, let's say, index 4 is not going to be including the whole original array. It's only going to be including the previous, potentially previous max subarray, including its own. Similarly for here, for index number 3, you do have the option of including the previous max subarray. However, that's not going to help you because this is a -5. And so what you end up choosing is the max between the current value and the n plus local max of the previous entry, which is -5. As soon as you figure out the maximum subarray ending at a specific integer, the only next step that you have to do is keep a global max variable, which actually doesn't care about where the array is ending. The only thing it cares about is what is actually the maximum subarray. And so these two simple max evaluations actually give you the right response. Now, how we're going to modify this algorithm in order to fit this problem is we're not only going to care about the maximum, but we're also going to care about the minimum subarray of the array. Why, you may ask? Well, the minimum subarray is going to be, in the case that it is overlapping, it's going to be the number that is directly complementary opposite to the max in the case that the max is wrapping around. Let's call this local min. Sorry, global min. And now let's go ahead and iterate through all of these local min, min, n. And at this point, the only thing that we have to do here is have s thumb of the total array. And what we have to return now is the max between the global max or between s minus the global min. Let's run this and see what is up. Let me see if let's check where this 12 would actually come from. For this purpose, let me remove the global min and actually check that we're counting global min correctly. Global min in this case would be -2, correct. In this case, it would be 3, correct. And in this case, it should have been negative. No, in this case, it should have been -7. However, we're getting -11. Something is up here. Local min is the minimum of n, the current value, and n plus local min. I see what is going on here. Instead of going and iterating through all of our values, we actually have to be skipping the first one. As such, because the initial local max and local min are the first value. Let's see if this is correct. This is still -2 because it doesn't happen to be the first value. This is -3, and this should be -8. Correct. Perfect. So now that we have this out of the way, let's return once again the max of global max versus s minus global min. Let's see if this works. and the output is 0. It seems to me that maybe the global max is being counted as 0, although the global max here should be counted as -2. The global min. Oh, what is happening is that the global min is being returned as the whole array. And so 0, or whatever sum this is, minus the global array, the global min is obviously 0. Let's think of how to avoid this weird edge case. How do I avoid this weird edge case if I'm thinking that could I potentially just assume that if my sum of all these values is also equal to the min subarray, then could I by default take the global max? That could be a possibility, except I'm thinking of what if there are some combination of numbers that, for example, happen to equal the sum of the whole thing. For example, if the sum of the whole array is equal to 0, and the min subarray is also equal to 0, that's not possible. So that's not possible. So let's say max subarray of global max and s minus global min if does not equal 0, else global max. Sweet. So, yep, that was the one condition that we had to watch out for, which was that if in some case the global minimum happens to equal essentially the sum, then that means that the whole array is considered as a sum, and we should disregard that. This could have been done a little bit cleaner. Let's look at some solutions, but before that, I just want to stress the simplicity of this solution because you could overthink this and say that, for example, since we have this approach where, for each index in this array, we know the maximally big string. For example, when we run the regular cadence algorithm, we would potentially figure out, if we run it from, let's say, this way, we will know what is the max what is the max array ending at this index. Additionally, if we run the same algorithm but from a different angle, for example, if we run it this way, we would know the max array or the max subarray ending at this point. However, and we could try to add to see if the max subarray of regular cadence algorithm is greater or equal to this plus this, right? But however, you start getting into edge cases where potentially, accidentally, you could end up overlapping some of these max subarrays, which is what this portion of the problem was stressing not to do. So a way simpler solution is to go ahead and think of the to the negative representation of the max subarray, which is the min subarray. And if we find that this happens to be the min subarray, it no longer matters where it ends, where it starts. We just take the sum minus the min global, and we all of a sudden get this excluded subarray, max subarray that is wrapping around from both ends. Now, this approach wouldn't work. For example, if you needed to return the indices of where those subarrays end or start, but I'm sure that there's going to be a question coming up similar to that. So, yep. So submissions, let's see if these submissions do something similar quickly. This is my submission. Minimum subarray, same approach. Min sub, max sub. Yeah, so fortunately, interestingly enough, and these ones do it in way shorter. Well, he just put everything into one line. But yeah, the approach, I would say, is being followed similarly for everyone else. So consider this a success. Thank you for sticking around. Catch you later. Bye.